Hey guys, the community edition of EVE is missing something that we might need for our labs. NATing. We need to access the servers inside of our labs, and in the Pro edition that is automatically done by a so-called NAT cloud. But what if we have, let's say, IPv4 to IPv6 network translation? I'm going to show you, and this time I have a little assist here, my JKitty, and I hope you enjoy this video. So as you can see, we have three different parts: an IPv6 only network, an IPv4 only network, and a transit network. The IPv6 is a Ubuntu server with the default settings. Our dual stack, v4 and v6, is a vSRX3.0, as you can see here, also with the default settings. We have another vSRX3.0 to represent the IPv4 only part of the network. And also we have a Debian server who tries to reach the desktop on the IPv6 only side. The Debian server will try to ping the Ubuntu desktop. The Debian server only has an IPv4 address, while the Ubuntu has an IPv6 address. After some time, your Junos is ready for boot. So log in with the username root and no password at all. Next, we go to the CLI to enter our Junos commands. In our case, the GE interfaces did not show up yet. It usually takes a bit of time, and usually after you see the messages on the left, the GE interfaces will be recognized. You can use the show chassis FPC to verify that your FPC 0 is online, and you can also check your interface strs afterwards to verify that your GE interfaces show up. So technically, you have all the prerequisites that you need to run your vSRX. Let's start by creating a simple point-to-point connection between our vSRXs on port GE000. What we need is a transfer network, in this case a /30 will do. We also need to assign the interface to a security zone, and we also need to allow Junos ping so that ICMP can be used from either of the SRXs. So in the first step, we configure the IP address under the GE0 interface subunit 0. Let's do that on both sides so we don't mix things up. And usually I take a little note so that I immediately know, okay, this network is between SRX A and B, and point 1 is the right side and point 2 is the left side. Next, we add the interface to the security zone. Trust and untrust are already predefined. Let's do it on the second side on our dual stack device. G000, and there it is. Next, we need to allow the host inbound traffic for our zone. In this case, I will only allow ping on both the SRXs. You should only configure what you really need. Don't use all. I usually do that from time to time in the lab, but in this case I wanted to show you that you can pin it down to ping. If you run a commit check now, however, you will see that there is an error because we need to assign a root password to our topology. So set system root authentication plaintext password will allow you to set up a root password. Without a root password, your config will never commit. You simply won't be able to commit. Now, after the root password has been put in place, we can use commit and quit to commit a configuration and to exit the configuration mode and get back to the operational mode. And if we now issue a ping, we can see that we succeeded. We created a point-to-point connection between our vSRXs and we can route traffic over it. Let's start to configure the hosts by focusing on the IPv4 only network. We start by logging in to our Debian server. We're already logged into our SRX. Now, to establish a connection, we need 2 more IPv4 addresses. And we will use the 172 range for this example. So go to your SRX. This will be our gateway. And we need the GE002 this time. We also set a host name, in this case vSRX v4 only, to reflect the host name on the EVE-NG GUI. Go to the interface 002 unit 0 family INET address, and in this case 172.16.0.1/24. That is our client network. The client network is inside the security zone trust, and on the trust side I will allow everything because, well, I'm on the trust side. And if I don't trust that, I have a different problem. Now the point 1 will be our default gateway for the Debian server. So go into the wired settings of your Debian server. And click on the settings icon. Go to IPv4. Disable IPv6. And now we will select a manual configuration. We will select point 100 as our server's IP address. Enter the address. Net mask is, who would have guessed, 255.255.255.0, and the gateway and also the DNS server will be our SRX. Currently the SRX is not doing DNS, but we'll change that soon. As you can see, the wired connection has now been enabled. So let's try to ping our gateway, our SRX. Go to the search bar, TERM, to get to the terminal. And now issue ping 172.16.0.1. And you will see, hey, the server is able to ping its default gateway. So now we have a connection between the Debian server and our v4 only SRX. We can do the same from the SRX towards the server. Since we are in configuration mode, we need to write run before the ping, but as you can see, this is also successful. So now, back to our GUI, we have established the IPv4 only part of our network. We also have the point-to-point between the v4 only and the NAT46. So now let's focus on the IPv6 side of things. Back at the lab, we connect to our Ubuntu desktop. We also need to connect to our vSRX NAT46. And as you can see in the topology, this time GE004 is the interface from the SRX side that we need to configure. Go to your vSRX NAT46 and set the interface GE004 family, and this time INET6 address, because we're adding an IPv6 address. I will use a private IPv6 address here as shown. Maybe you can figure out what IP address I used. There is a little hint in it, but I'm sure you'll figure that out very easily. 64 is the smallest subnet that we can use. And that's more than enough addresses for all the JKitties in the world times, I don't know, 60 million. The GE004 is also added to our trust security zone. And inside the trust zone, we can simply allow everything because we're inside the trust zone. In the Ubuntu's wired settings, this time, we will disable IPv4 and enable and configure IPv6. So we again change it to manual, and in the address field, we simply type the address that our Ubuntu desktop host should receive, with the 616E at the end. And for the gateway, just copy the address, paste it, and change the last to 1. The same is done for the DNS settings. Hit apply, and now our IPv6 only desktop has an IPv6 address and no IPv4 address at all. Go to activities, to the terminal again, and try to ping your default gateway, in this case the vSRX NAT46. And as you can see, this ping will work. So now we have successfully set up the connection from the Debian server to the v4 only via v4, to the NAT46 via v4, and via v6 to the Ubuntu desktop. But the Ubuntu desktop still can't access the Debian server and vice versa. We need NAT46 to change that. So let's do it. We have successfully configured IPv6, but our IPv4 network is still unable to talk to our IPv6 network because we are missing NAT. In this example, you will see a NAT46, so the translation from a IPv4 address to an IPv6 address. And we're doing that by using the proxy ARP feature on the vSRX. And I'm going to show you how. We need an IP address that our Debian server can ping from the v4 side that will be translated to the v6 address. And we use a feature called proxy ARP for that. So on the interface GE000, we basically add another IP that the SRX will respond to for us. So in this case, 10.10.10.3. This is not part of the 30 range that we configured earlier. It's an additional address. /32 will do it. Next, we need a static NAT, which we will call NAT46 from the zone untrust. And then we need to create a rule to match the source address and destination address. In this case, everything that's coming from the 172 1600. That is the source that we are coming from. The destination address is our 10.10.10.3. And you need to type that out completely because the SRX doesn't like it if you type and then use some spaces. After we have matched the source and the destinations, we tell the SRX to do a static NAT towards the prefix, and then we enter the IPv6 address of our host. So FD43 6872 6973 7469 616E/128, because we're just referring to one host. We have changed the NAT for the destination, but we still need to change the source for the hosts to communicate. So in this case, we use a source NAT and we call it NAT46 from zone untrust to zone trust, because from the SRX's point of view, our v4 is coming from the untrust over the GE000 to the trust. So we match the source address of our IPv4 client network 172.16.00/24, the destination address of our IPv6 host, because static NAT takes place before the source NAT, and we already changed the destination in our static NAT. So we need to type the IPv6 address here and not, as you might have guessed, the IPv4 address. That is very important. And then we simply tell it to do a source NAT interface. So just replace it with the SRX's IPv6 address. And after a commit, in theory, we can now communicate. But we're still missing some policies, as you will see soon. But our NAT64 vSRX still doesn't know where the 172 address is. So we need to add a static route on our NAT64 vSRX. Just tell it that the 172 address range is behind its GE000's partner IP. So a next hop of 10.10.10.2. That basically tells your NAT64 vSRX to route the 172 towards the v4 only. And we also need to add a static route to our v4 only, because we have the same problem with the 10.10.10.3 there, because we still don't have a default route installed. So just tell it that this host is behind 10.10.10.1 and you're good to go. If you're going to the Debian server now, logging in, and then trying to ping, however, you will see that the ping is not yet working. We have established a connection, but it seems like our firewall is still blocking something. So let's go to run show security flow session to verify. And as you can see, there is no answer. It's 0 bytes. So that means we still need to do something in our firewall. Let's do that. Let's add a security policy to allow ICMP and ICMP6 from untrust to trust. There is a general discussion if you should allow ICMP. I'm a big fan of allowing ICMP because security through obscurity is no security at all. And blocking ICMP will basically limit your capabilities to troubleshoot. But that's just my opinion. There are some smarter guys out there who think otherwise, but in my networks, you're always able to ping the hosts that are alive. After the commit, we have the firewall rule in place. So let's try to do the ping. As you can see, the ping is still not working. Maybe there is another rule blocking it on the other firewall. To quickly verify that, we can set the default policy to permit all. That's usually a hack that I do in the lab to verify if it's the firewall rules or if there's something else wrong. And as you can see, now the ping is flowing. Means we have to create another security policy on the vSRX v4 only. Or for this lab test, we can just leave it at the permit all because we are inside the lab. The permit all, that's a quick way to figure out if you have a configuration issue or if you have a policy that is missing. So now our Debian server is pinging the proxy ARP IP, the 10.10.10.3 of our NAT46 vSRX. The vSRX translates that to the destination of the IPv6 address and also changes the source so that the traffic can flow. And the answer back is also correct. So even now we're pinging 10.10.10.3. In reality, we're pinging the IPv6 address. And that was NAT46. That wasn't so hard, right? That's it. We successfully implemented NAT46. So from our IPv4 network, we can now access the IPv6 network behind our vSRX. In the next video, we'll do the other way around, because currently our IPv6 only server cannot reach the IPv4 world. That is covered in the next video. See you next time. Bye!